Welcome to this AD seminar. We have Christine Darve, and she is an electric engineering scientist at the European Spallation Source here. And she earned her diplôme d'ingénieur from Institut Polytechnique de Sévénon in France, and later obtained her PhD from Northwestern University in Illinois. Her career began in 1996 as a student at CERN, the same year I was born, actually. Where she worked on cryogenic development. She then joined Fermilab, spending 12 years working on Tevatron operations, contributing to the commissioning of the LHC while building large-scale collaborations. Additionally, she worked in test stand design and operations for projects such as the Muon Collider, Liquid Hydrogen Absorber, and the first SRF cryomodule, and other high-energy physics initiatives. In 2011, she joined ESS, serving as the internal work package leader for the spoke cavities, work package 4, and elliptical cavities and cryomodules, work package 5, until 2019. She now works in the in-kind management division, ensuring the successful technical delivery of ESS equipment. Beyond ESS, she is the chair of the International Union of Pure and Applied Physics Working Group, 14, and a former chair of the Forum of International Physics, at the American Physical Society. She co-founded the Nordic Particle Accelerator Program and the African School of Fundamental Physics and Applications in 2010. In recognition of her contributions, she was named APS Fellow in 2016.
Thank you.
Very welcome.
Thank you very much for this nice introduction. So indeed, I was actually I have to see how to find the best way to share. Now it's working out. Okay, so indeed there was a play on words, and I think that you kept this apostrophe, so I just wanted to take this back, because that's always like the reference, where we're coming from, and what is the local aspect for each of us, so personally, and then how to translate this actually in a term of more global way. So maybe in addition to this short description, so my research was more on the superfluidity of helium, so it was more also a service for or a user for the magnet or for the cavity. So this is why I could adapt to some of the different accelerators in one sense. And then I wanted to point as well at the very beginning, indeed, last millennium. So I started to be active also in all those activities, so in parallel. And I call it vintage because indeed this is a long time ago, and I started to keep my bookmark in this web page, so where you can find as well most of those different information. But indeed, what I will speak about is a mixture of both how to transfer this knowledge, so this technological knowledge shared also between the different research infrastructure and ESS, so over the time. But I think it's the important thing, because we have not too much explained as well some of those platforms that we have developed here at ESS, with also in collaboration with the light source. So this synergy between the light source and the neutron source. So this is those tools that I would like to emphasize a bit more. And then some case studies as well, based on those international community in which I've been quite active for several decades, I mean, at least 2, let's say. So technological knowledge transfer, so everyone knows the ESS and the in-kind management. So this is where, so now I'm more based, but again, remember how we started all of that. So some of you were not there yet, and some were here much before me. That's also the interesting aspect. But the idea was to take the synergy as well of the knowledge existing in those different countries, in the different labs, and to build up as well as capacity from this green field. And green field in French, this is Prévert. So this is Prévert, you know, the poet. And I think that we are still like a bit on those words. So this is both this research infrastructure and the project to start together. So this is why also it has been challenging, and this is what I think is important to kickstart this challenge with a European country. So expression of interest, this is how we started. The country need to have a will and need to have the knowledge to be able to construct so what we have now, which is mainly based on this in-kind. So indeed, when I first arrived, so I was for 8 years, so working on the cold LINAC. So indeed, superfluidity was useful in that case for the cavity and the crown module. And because at Fermilab before I was developing so this hardware, and this is so without naming everything, because I guess that all of you know this very well. So the normal conducting aspect and the supraconducting aspect. So for my part, so with the work package 4 and 5, the idea was to build up the prototype and then to launch the series that now is being tested. So with Paolo Perini, whom as the SRF expert, and with Cyprien, give this possibility to make sure that the beam that Mamad had designed can really reach the target. So the idea is now so that everything for the accelerator, for my part, so I wanted to see a bit more, so this is why I moved to the in-kind. But then what I wanted to come back to is the idea of those collaborative exchange as well. And for the case of the SRF, so again, my own background, so the idea was to see in terms of Fermilab, so again, 12 years I spent there, and we had the first cavity being tested, while it was new as well. So we had the first crown module being tested. So by chance, I was also at that time. And some of the lessons learned as well, we brought when we designed together with our in-kind, the first crown module. So technologically, so there is a lot of knowledge transfer that we took in order not to mislead too much or to slow down the project. So the aspect of, for instance, Fermilab, you see it here. So this was also a place where we had the different compressor, the different cryogenics equipment installed, and where the first crown module were tested. So all those different designs come also in a case of the segmented approach from the SNS, the crown module, warm magnet, crown module, warm magnet, instead of the XFEL, where we had a longer so crown module. So in order also to be a bit easier. And I guess that maybe so we can see the positive or the negative with all those interface to have to open or not, but I think this is a good choice anyway to have warm magnet. But all this knowledge from so the European country have been put back into so this those crown module in terms of those cavity and crown module. And looking at the clean room, for instance, that's another interesting example, because 2001, so when we restarted at Fermilab with the SRF aspect, so we had also this clean room that was installed. And in 2007, somehow, Antoine Del, so if you remember him from CA, came to get as well the idea on how at CERN they would get the same clean room. So you see this exchange of expertise, and that clean room at CERN was used for the XFEL. And then we came later in time, so this is also best for ESS, because we gain as well all this knowledge in terms of how to expedite and how not to redo the mistake that were done at the beginning. And there's a long list of that. So coupler and all of that. But with, so you recognize here as well some of our dear colleagues, so from also from Italy, and the clean room as well, so from the CNRS. But you see here, so that was this inauguration from an additional clean room that with the support of the funding, so we get the possibility to inaugurate and with so Matt and so the CA director. So I could spend a lot of time in this aspect is which now with the in-kind and looking at the different equipment from Target and the NSS as well. But then the idea is just for you to record that there's those web pages that exist. So I've tried to put there as well a kind of logical way for the in-kind to be able to access the material and to provide the knowledge, like all the different compliance that we will need to be able to operate, because we need to operate as per the Swedish law. So this is the requirement. And there is a lot of TA, so technical annex. So this is all the bonding document that connect us with each of our in-kind to produce the given material and equipment. So meaning that knowledge transfer is the manual to operate with equipment and a lot of other things. So I'll not go into this detail, but have a look, and then indeed we can look on specific case. Just to mention as well this database where I try to put chronologically in terms of what is the status of the different sub-project and where the different web pages that are important. But again, it was done before the rejuvenization as well of the website at ESS, so there might be some redundant. So anyway, so let's focus on those platforms for global knowledge sharing, because I think what is important is this digital world. So somehow I've been also lucky from last millennium to have been at CERN at the right time as well. So if you don't know him, this is Robert Caillot, so the co-inventor of the World Wide Web. So Tim Berners-Lee was the one who invented that at CERN, thanks to high energy physics. And then we had Robert Caillot, who stayed at CERN and who was managing that group. So because I was at that time, so with Physics Sans Frontières, so I became the secretary in 96, 97, we decided to have a summer school in Sarajevo. So CERN is a big player into this fostering as well, information sharing, those digital platform. And I like to, so you can find, so this Physics Matter, which is a special edition, where we had something similar, but with much more detail. And the recording as well were 2 years, so after, and actually 30 years after the World Wide Web was launched. So you have this recording and CERN gathering everyone, and you can hear the words as well of Robert Caillot, which again is the wisdom. We have all those revolutions. What do we do with that? We need really to make the best use of it. So now it comes to AI, quantum, and all those aspects. So this is what is the aspect. So revolution and evolution. I always like to get that because it's like, what are we basing our organization, our society on? We had this industrial revolution over the time that enabled to base this scientific knowledge and then to grow this into a technology and equipment that we could use to have then the industry using this so that we can use it like our smartphone, so on a daily basis. So this revolution for information is also the most important one, I would say, for us, because of development, the solid state that gave birth of this World Wide Web, now all those different platforms that we have. So those platforms that we use nowadays. And for the life science aspect, for the ESS, the additional value as well is beyond material. What we do is also for this molecular, for this biology. So all this knowledge, we put this as well into this ecosystem that I would call so the research laboratory, research infrastructure like ESS, mainly for the scattering technology, but it could be as well high energy physics, connected with the university because you need the given project to base this fundamental research, and then the industry to be able to build up on that. So those links are fundamental, and this is what we need really to find the best connection and way to implement. So case of Max-1 ESS, so this is those fundamental particles, indeed with the photon and the neutron. So I really always like to have this idea as well of how much we need to work with the light source and then the neutron source, because this is the scattering community. And then you have the high energy physics community, which sometimes it's the same kind of methodology that we're using, but there is always some kind of different community. So to bridge this community is the essential part because we have the same need and the same method and the same tools. So photon, neutron, electron, if we look at the light source, but also proton acceleration for also the case of our accelerator. So in a nutshell, really quickly to recall that both are important, and I guess that all of you know, I like also this picture of the Buddha in one sense. So that's Leni Rifkin, who is a colleague for a long, long time also, who provided it. So from PSI, when you see with X-ray, because the X-ray will knock on the cloud of electron around the nucleus, then you see when this is like a heavy, like a large Z, so like it's a metal, you would see it well. But if you have neutron eyes, so it means that you go through the cloud of neutron, and you get the possibility to see especially the hydrogen and as well the deuterium or the different light particles. So looking at how you would see with X-ray or with neutron water, H2O, and knowing that with life science we have mainly like water in our body. So this is why neutron are super important. But as you know, we have a lot of light source because electrons are easier to generate. You don't need those big energy. So this is also cheaper, and this is also showing that the bonding, the hydrogen bonding for the molecule, for the protein, for the life, this is really important to have those neutrons. So that's also the aspect of the training. So not directly in digital format, but in person. We had with the French embassy since 2017 roughly, so we started to develop as well for the user's perspective. How will we in Lund get possibility to attract most of those users? And between those two countries, we wanted to have also the return on investment of the French for the accelerator, because this is where France put a lot of the financial support together with the instrument. So France wanted to have more connection as well, so with this community. So we had in 2019 the possibility to develop that school, which is advanced because it was PhD student mainly in the field of the scattering, technology. So for environment and material, that was thematic. Then we did in 2024 another one, which the thematic was based on life science. And same way, we would invite roughly 30 different students, so PhD level, that would together work on some project and learn about the technique that we will use and how to best fit as well the instrument that we have here with ESS. And then 26, so we are planning another one which will be based on energy and nuclear. And nuclear because with the visit of the President Emmanuel Macron and then the King, so the idea was to strengthen as well the link for the nuclear. And with Alpha Laval as well being in the contribution, so we tried really to get, this is one of the reasons why we will have 26 this school, this time in Grenoble, not host at the links, but in Grenoble. And we will as well bring the student from those different French university and Swedish university together to build up this aspect.
What does nuclear mean?
Nuclear, so it would mean
nuclear energy.
Exactly, not carbonize. I mean, decarbonize in that sense.
Nuclear energy.
Yeah, exactly. But we want energy. It means as well the battery and all this aspect. So that we didn't have so much with the environment and material. That was more like for the photovoltaic or thing of that side. Also energy. So. And we want to have it every 2 years, really to get like a better bonding as well between the French and then the Swedish government as well. So then there is this alpha that I wanted to mention as well, because some of us as well are involved in that, and especially this is the C2.3, so looking at challenge-based innovation, because also in a thematic, I like the way they have looked at how particle accelerator, but from a point of view of engineer, like scientists, economists, lawyers, can work together on projects also on those thematics. So there are already 3 editions, and there is a new one that will happen as well, that gathered students who are more like bachelor and master level, but that give possibility as well to bring this new way of thinking. So again, if you know students of that style, so in the diverse discipline, you should recommend that. And the last one we had, for instance, was application on medical, which I think was really interesting as well. We had Amaldi also, Hugo Amaldi giving a presentation, so it was really interesting. So now if we focus back on particle accelerator, indeed a lot of them evolving all the time. So I guess all of you have seen Oppenheimer, the movie, which was, I think, great, long, but very, very interesting. And then you see a bit more of the history about how with Lawrence, I mean, it was like those accelerators and how you really bring this revolution in the middle of history. And this is high story, I would say even. But that was really interesting to not to see too much about Chicago. I mean, that would have been nice as well. But then to see the scale and what those small particle accelerator, I mean, it was already big at that time for what he was using with the synchrotron, but he started with a small one that became gigantesque with the LHC that we all know now. And again, I had the chance to work both for the Tevatron and the LHC for the commissioning of all of that. But most of them are applied for medical or applied for all those young implementation. And this is what we tried also with Sojo and with the team to try to enhance as well, to show what particles accelerator are used for. A lot of already existing materials, again, we don't want to copy, but we want to reuse some of the past that had not been maybe looked too much in detail. So there are some university program, for instance, in Aarhus or Lund as well, with our colleague from Max 4, the joint university, the JUAS as well, so where, Cyprian and Mamad, so you're also part of. So there are a lot of ways to connect directly with the student, but sometimes this is, the JUAS, for instance, is 10 weeks, the CAS is 2 weeks, it may be a higher level. So the idea was to try to target the younger audience. So there I list as well those that are more for the scattering community. The Hercules, for instance, also 10 weeks, or photon and neutron. This is now this e-learning aspect, or the CCAT, the scientific catalog, which is really an interesting thing that we are also developing here together with the DMSC. So back a long time ago, 2015, while actually, and also based on the fact that I had already started this African school, that's also one of the reasons why I'm here in Lund, but the idea was to start something on finding ways at Lund to picture, so the Max 4 and then the ESS together. So we had one first school, a proof of concept, and based on that, so we wrote an application, Erasmus Plus, strategic partnership, in order to gain 2 more schools face-to-face and then develop this MOOC. And this is based on those existing courses that were already ongoing. Based on the support also of the links, we had then developed those MOOC that I'll discuss a bit more later on, which since 2019, because it was finished just before the COVID as well, and I think that was a chance, otherwise we would maybe never be finished. But we have now more than 20,000 learners. So this is really good. And what we're doing, we are showing what light is, what Max 4 is, what ESS is, what all those accelerators like the LHC for collision are. And this is those little movie that you can look at your path for free and then get the knowledge of that. So we didn't do one MOOC, we did 3 of them. So it means that this first one was introduction. We have a second MOOC that you can take independently, which is how you can build an accelerator, maybe not your own, but then like what do you need in terms of the equipment to be able to build it. And so that you see all of those courses there. And then the third one, how do you apply accelerator? Again, I like things that are pragmatic. So we looked at how medical accelerator were done. And there we have one of our speakers, so who is from Aarhus University, who describe all of that. Now it's done thanks to Coursera. So this is in UK, but they have possibilities. You see, it's about 17 hours of your time that you will spend looking at the different courses. Here, so we have video. So each are like 2, 3, 5 minutes long. Then you have quiz. Then you have like some reading, and little by little you gain and you have much more knowledge, and you go at your pace. You don't have to get one to pass to the next one. You can jump. So it's kind of very, very convenient. So with Anders Carlson from the Lund University, so we had our team, so that you saw before, bringing this together. And important, because this is also the thing, he's there, so for life. And this is what we had recorded. So we have actually seven different little movie. And we took at that time the material that we had, so meaning not the real accelerator, but then this step 5. So, and this is something which I think is good, because you see the sustainability of the project. I think this is really important. And again, I mean, you see what I mean. That's good and important. We didn't indeed do so much publicity at that time, because there was the construction of the ESS, but then we should maybe do a bit more writing, or to try to rehearse that. But based on that, so MOOC, we wanted to reach out younger as well, and with so the support as well of Joe. The idea was to teach teacher, because then you can massively, the idea of the massive was also to be able to reach out a larger group. So you can see much more detail from so this presentation here. And this accelerator teaching was born. Same way, like a grant for the Erasmus Plus, and we get there a larger group with as well Belgium, so SchoolNet, EuroSchoolNet, which is whom very professional in one sense. So they had a platform really very well tuned for a high school teacher. And then we present different things, because their accelerator, yes, it could be useful, but then they already need to know the forces, the magnetics, the structure, the electromagnetic. So all those aspects, we try to use pedagogical tools, some stories, some games, so race to space. So same way, it's for free, you can register and you can race to space. And in that way, you become one of those scientists, and you try as well, like all the different scientists that we will have now on our instrument, being able to prepare everything. It's really the scattering technique at application. And those learning scenarios, so it's also with the Aero Forum, so a platform which is very, very convenient. So you can select the different language, the different age, and then you will find what you need for the thematic that you want. So there are 3 of them, so that Joe had prepared. And this is really something that will gain also momentum. So the idea of those learning scenarios, possibility to build your own linear accelerator. The other case was for the scientific story. So what we did was to record some of our scientists. Not all of them were from ESS. So we have Christina and Zoe from ESS, but Carsten Welsh and then Phil Manning. So both of them are from UK. So England is very strong with all this capacity as well for scientific communication to pass the right message. So you hear the story of Carsten speaking about particles. He's also a physicist in the LHC. So you really see this particle aspect, and he's excellent by putting for high school students. So the idea that they're gonna understand what Star Wars is made of. So you see what the lasers are made of. Is it feasible or is it not? You see the space. So you understand much more concretely in a game way as well, what things are. And Phil Manning as paleontologist, so he really brings you back to the time and how light source could be used as well to understand how those dinosaurs were working, or walking, not working, I don't think so. But then it was, so it's really fascinating. So indeed, when I interviewed him, I was thinking, oh gosh, if I was 19, I would do that field. So this is the thing, scientists can really bring you to that direction, to what would become, so the future as well, and bring this kind of society being more prepared in one sense. So you can look at all of that. This is also on the ESS Explore, and this is open to everyone. We had, so reach for those teachers, so there was like 2,500 teachers, I think, the first week. So that was the idea, to engage. A lot of them were indeed in Greece or in, and as well in Turkey, I think. So that was really impressive. So again, English language, but then we can have CC, so we can always find some way. So maybe that's also the thing we always need to improve. You have some little trailer description. So pass the word as well, because I think it's really worth it. And then we had a dear colleague called Susie Sheehy, who is also from Oxford and who was in the same university as well than Cyprien. And she's a star. She wrote books as well. She really speaks very well to the public. So we had some of her movie as well in our little presentation, MOOC. And then we were using actually her little movie to try, it's in French. Why? Because we try to benchmark this. So with African school. So you see, this is the same thing, because I'm involved in many aspects and I don't want to waste too much time. So I use, and massively this is good, because this is what you need in Africa. So the case of developing community, you need really to spread the word as well. And that was perfect. So it was in English, but then we could explain this in French, because I was with a colleague of mine, Sana, Sam. So she's from Italy, but she's now based in the US. And she was speaking Arabic and I was speaking French. And we could really, with the high school learner, have like a really interesting time. Again, short movie, it's exciting for them. They can understand better. They can ask questions. And if you see here, so we had those games, so that we had also, so with Joe, so looked at and developed how to accelerate those particles, how to use the energy, all the aspect of, the kinetic or the potential energy, everything. And we were even building some accelerator, like by pushing, giving the energy, and then if you're an electron, a proton, so you bring to the students, I mean the kids, let's say, the possibility to understand what particles are and what you can do with that. And it had a great success as well with the government there, because looking at they were just restructuring as well in Morocco, so the education, and that helped them. We had more with the ESS, more than 2,000 learners. So that was the capacity as well for that school. So I can't prevent speaking a little bit of that school, because that's something that for me was an eye-opener back in 2010. So I was part of this group, and then I became the main organizer of the first school in South Africa, because there is an accelerator. And the idea was to bring together students from everywhere in Africa who could not otherwise go to other places. And the idea is to pay them, so the trip, and then to have our professor coming from all those large institutes giving the course, so 3 weeks initially, and the idea was also to have VIP showing what they could live as well in each of those countries. And we had then built up now conferences, so this is why we have conferences 1 week, then 2 weeks of school, and we alternate, so the different countries as well in Africa, so that it could be like, and this is massive. So for the high school, for the teacher, more than 70 teacher each time, and more than 2,000 learners each time. So again, massively. And now we have our MOOC, so we really try to bring visibility. And again, could speak for hours about that. So you have those references, and if you need more information, just let me know. But it's physics in a nutshell. And you know, we are all specialized in one field, but it's important and interesting. Sometimes we're curious. So we want to know what those experts are saying. So you have particle physics, light source, and neutron source. Of course, I push for getting more of that, with all the different cutting edge, depending on the country where we go. Because we've been so in South Africa, in Ghana, in Senegal, in Namibia, in Rwanda, and the part is depending on the country, they have different interests. So for instance, AI was one of the interests in the side of Marrakesh. So then we develop more about that, or like this machine learning. So to engage the society. We were right in the middle, of course, of the pandemic, and we decided also to have it online. So in this online series, and again, you can find all those recordings, sustainable, all those courses for the best professors in the world captured there. And we had this small mini series, I would call, for photon and neutron, where we had Andrew Harrison, so who was at that time director of the Diamond, and who gave 6 of those lectures. And then we had our colleagues, so Andrew Jackson, Pascal Dean, Robin, speaking about how ESS for the neutron aspect would look at that. So you see, it's back 2021, and this is all recorded. And this is part of the school. And Valentina gave for the high energy connection, because a lot of our students, I mean, again, background from high energy physics Fermilab, you could imagine that in the selection committee, we might sometimes be a bit biased and have a lot of students who are with this background, high energy physics. But we insist on what is useful for their developing community. And quite often it's material, for instance, or life science. Again, much more information that you can click on. So now, case study, international community. I have 3 of them, but I would like to spend just a bit more time as well on this A case, which is the Forum of International Physics. So the idea, it's American, okay, but American international. So this is this idea of building this hub for all those international forums. So the Forum of International Physics, so we have 4 in the sharing committee. So now I'm former, so I just run this outreach and communication committee to go on with this physics matter. But the idea is that every year for the APS meeting, March and April, so we invite the different speakers for thematic also that we define. And there I gathered all the different, about 50 different invitees that are really with, for instance, Rolf Feuer, or people who present science and physics as well in a very clear way. So this is satellite meeting as well that we have enabled in the world, like for instance in Jordani, having possibility to hear what is happening in the US. So the problem sometimes is the time, and because the Earth is not flat. So this is what this FIP is doing. We have also distinguished students. So we identify students that are very talented, and we pay them the possibility for joining the APS meeting. So we have award as well for some of those researcher or traveler to be able to move from one institute to the other, a special one also for Ukraine. And then there are some nominee and some different awards that are important. So Physics Matter and the newsletter. So Physics Matter, you might have heard about that or not, I don't know. I hope not to spread or to spam too many people with that, but it's just like once a week. And the idea is to give possibility of focusing and connecting. So for 4 years now, I've been already operating that. We have 53 science events. So it's really global and it's open to everyone. So I managed to find with the APS a way so that you don't have to be member, but you can access to this Zoom, and then you can connect from everywhere. Even in China, they have Zoom and they have possibilities. So you connect US and China, and then there were a presentation which was superb from Professor Han Ying, who was describing all the accelerator-driven system. That was, for instance, one of those presentations that really give possibility to connect and to show. So again, we had a lot of them, and we can really connect a lot of people depending also on the topic. And the idea is, so this is, 20, most of the time 40 minutes, because the speaker needs some time to express what they want. But after we open the microphone, and everyone can ask and raise questions. So I think this is really the added value also for everyone to be able to connect from everywhere in the world. So that's really the idea. So topic, so Sesame Light. So this is how we started, because in America, there was the idea to support Jordan, where there is this light source. So again, photon. So this is why I think it was interesting to have both community, scattering technology, scattering community, and high energy physics. So in those Sesame, there are 8 countries. So then who are members to support. So one of the first way was to have some of those colloquia in each of those countries, to have a mapping as well of what they're doing in each of the countries. We had actually 2 in Palestine, 2 in Israel, in Pakistan, in Turkey. So really all the countries that are typically not working together, they can work for science, let's say. And Iran also, it was a super talk about all the AI. So with Karimipur, huh? The name is not really easy, but and Reza Hashada, voilà, exactly. So this is why, again, how with education, we can also picture how particle accelerator for also the observer. So we had, for instance, Katarina Biscari speaking about the ALBA. We had in the Sirius, Aris Westphal presenting as well this observer with how light source and how they develop those light source. We had the African light source, we had a project now, or the Caribbean one. So again, 53 of them and a lot of information, trying to focus also on organization, Engineer Without Borders, Physics Without Frontier, forum and topics that are often like climate change. We had UNESCO as well presenting the Sustainable Development Goal. So again, a mine of information when it's cold outside and raining, so you can look at that. You can skip whatever you want, but I think it worth it. And we have also our Carson. So with this laser and showing what we could do. The trailer was also made so with CERN, so with the support of Paola Catapano and then Luisa Cifarelli, who was the initiator of all this program at the beginning with some pre-recording one. And everything is on YouTube, so it means accessible. This maybe not from China, but at least for all of us. And the idea is this source of light, again, the photon scattering, if we look at this community, and then wall of ideas. So that was really nice because the origin of the sesame, so then I had 2 special editions on that. Herman Winnick, so I guess in the photon side, so on the synchrotron, so you could hear a lot of about him because he was so the founder more or less of all those Wickler, all those kind of lights. So, and I met him actually during the African school in 2012 when he was 80 years old, and this person is amazing. So then it turns out that with all those things, later on, 10 years later, he was 90, and then I met with some of, actually, I received some of the archive from the Sesame by Adayona, whom I met as well at the APS, and we decided to make a special birthday for him, inviting his colleague and the people who were the origin of the Sesame. And this was something that was, I mean, it's unique. See, we can connect as well, reconnect, even at 90 years old. And we were expected to have as well Erwin Chopper, who was 100. So he was not 100 yet at that time, but it was in the middle of the summer. So then actually it was Elise Rabinovich, who was the next most important person, who took as well his word. And then Elise Rabinovich had his own physics matter looking at from the beginning, from the Israeli, how all those things started. So again, you are in the history, how all those research infrastructure can be built. So I find it fascinating. But so, and then when you have, for instance, so 100, he's 101 now, 28, and meaning that he was soldier during the Second World War. And Elise Rabinovich was from Israel, also from his family was in the camp. But you see, for his 100 years old, so you see this connection, how science can really bring all of that together. And the book is online and is open for everyone. So for all these 100 years of history. And some of the newer ones, so with now quantum. We are starting the International Year of Quantum. And this is, you have certainly heard about what UNESCO had launched. And we had someone as well that you may recognize, because for us also he was in charge of all the CEA, so support. So while we were discussing the crowd module at the beginning, so he was in charge at that time of the ERFU. So Philippe Sommaz, who is excellent also in terms of providing, I mean, he's really like explaining very clearly as well, and he has a lot of outreach, I mean, presentation. So this one is, he has a TEDx as well in French. So if you want to see this and learn more French. And he had then in this, again, 40 minutes, but then it was really clear and very appreciated as well from, this time we were about 200 people. But again, that's really how we can have everything accessible on YouTube and being able to be reused. So we had, for instance, so once a month, so the one in November was the 70th anniversary of CERN, high energy physics, with Luciano Mossato, who was representing for the full year, so this 70 years, and he gave a perfect presentation as well on what CERN has been from the high energy physics point of view. And we will have the next one, which will be the application. So here, I want to show also what, so we had Giovanna Fagnetto as well presenting. So in May, so that was last year. And I wanted also to underline, because it's life science. So back in 2010, I was speaking about Ada Yona, so the Nobel Prize for crystallography. So for us, this is really the important character. She's the one who provided me all those archives from the Sesame. And then this is with Max von ESS. So one of the presentation that she gave. So again, YouTube, you can watch this out. Again, this lady who was already like 82 communicating with Lund University, a professor who are retired. But again, they were about to solve the problem again of the COVID, you see, like going back in terms of understanding how you work together. So that was fascinating, I found. And then the next one, so to speak about, again, CERN, how application with Maurizio Wetzner, so some of us know him as well, and he will give a presentation for Accelerator and Society, looking and focusing maybe more on the medical aspect, but also, you see, looking at for the energy and for all those aspects, because he's in charge, for instance, with the Tiara to many important development for accelerator in Europe. And for those that, this one might be a bit more technical, but with Malik Mazar, who was also from the IUPAP, quite well recognized as a fellow. And he will describe cold neutrons, so with this aspect of quantum trapping. So we can there go in more depth with this aspect, that we will have more like industry and research infrastructure and this IAPS, so young generation with students getting possibility as well to be part of the society. So again, there you can click and receive this automatically. So I think it's also a good way. So, and then you can read more, and then you can watch much more data if you want. And you even have a playlist, and all the events are there. So it's you're more than welcome to also spread in between your group, because I think it's not always easy in the APS to find the right way to communicate. So case B, this is going to be super short, and case C as well. So only 5 more minutes, okay? Because then we need to break. I think it would be the good time. IUPAP. So international as well. IUPAP has been presented as well. I had, I think, 2 or 3 physics matter on their development. And again, working group 14, looking at accelerator. And then with this mandate, because Matt was also part of the group. And then, so now I'm sharing that group with where we have also, so Suzy Chevy that we're discussing about. There are 22 different experts from 18 different countries. So I think this is really bringing possibility as well to have at the top of those different accelerators some voice and some common way as well to make use of those accelerators for useful things. So connecting with industry, this is one of the way IUPAP want to also drive a bit more to include corporate, and then to look at application for so laser and all those laser plasma acceleration, I mean, all those wake field. So this is also part of the people that we have in those experts. and people looking at also indeed the scientific case. So what light source could bring or what neutron could bring. So I think it's a heavy ion. So medical application with a cyclotron, getting all those things. Now that's also something that is a new mission for 2 weeks ago with this resolution. So we will include, we will find a way to maybe modify a bit the mandate to include this, so major neutron research facilities. But I think again for us at ESS, this is a plus. And this is working more with SNS. And we have already, so Fulvia, I mean, the head of the accelerator, Pilar, working with us. So we will look now with reactor and accelerator, at least for the neutron part. So what we do for that, so there are some way to map what are accelerators in the world, what they're doing, how we could improve that. We have, so this IUPAC, because IUPAP, one of the big missions, this is to sponsor and to get the endorsement for conference around the world. But we would like to do a bit more. So we had this call for ambassador, for instance, where also with our colleague, so Suzy Chevy, the idea is to try to identify in the world some young, I mean, students / postdoc that could really speak up for the case of accelerator, being kind of influencer as well, and try to bring as well more of this, what we can do with accelerator, medical, like climate change. There are a lot of things that people don't know. So this is what we would like to do. And we have short recording so that we have now prepared. You will see the funny, it's quite interesting. And then some hackathon that we want also to build up with STFC and other groups. So quite a lot. And then we had actually, that was the interesting thing with the UNESCO. So they would like now with so the new president as well of the IUPAP that we build up a short series of seminars. So with UNESCO, because also of those sustainable development goals, climate change, I would say, and this quantum aspect as well. So this is a short series that we are planning to develop. And Casey, so I will go very quickly because maybe some of you are interested, but the idea is there was one application, Infratech, that we didn't get, but that was, I think, a way to bring people together. The idea of using machine learning and all this aspect of finding an easier way to control and to operate our accelerator. So I'll let you click on that to have all the data by the person who was in charge of all of that. A lot of capacity as well to build with those working groups to organize with those fairs and the development of the method. So you have really the methodology that was well thought in order to standardize the way of approaching data processing or handling with accelerator, using all different instruments. And we have here, so yeah, Mamadou Otomche that is also involved in that. So at least the seed is there, and there is some different actions. So Carlson, again, Welsh is also involved in that, and we get so the possibility to share that. So in conclusion, so indeed, this is this open access. Okay, we as scientists, I think it's also our responsibility just to be able to share, to communicate, and to learn as well, because we need to know what we speak about. So that's why the idea of bringing or bridging those communities, I think it's important. So those MOOC, again, because you do it how you want, when you want. The FASEM, because this is as well with this capacity for directly ESS and Max 4. And then this accelerate your teaching, because all the academic level are needed. This is really the high school student for today that will certainly operate also the ESS if we look at that. So it's kind of a stage approach and how to motivate as well the public and everyone. So indeed, by sharing and indeed, like all those aspects of particles give possibility to find a way to have a little bit of impact in our society. So indeed, I put those after work as well somehow in the idea of how with ESS we can combine and we can make it be. So voilà, so that was the aspect. And remember, there are a lot of click that will bring you in detail to those detail. Yeah.
Thank you very much.
So
We have
you.
time for maybe 1 or 2 questions. No.
Where do you get that much energy, Christine?
You don't sleep, that's okay. No, but this is important. Again, we are here. We need to do something with our
It's
so
a very impressive program. It's incredible to see how much you're doing for all this knowledge transfer. I think it's fantastic. And I have the same question. How can you cope with doing all that? Yeah, I
It's
know that you work with-
motivation, you know that, yeah.
Yeah, I know.
How did you get started with, for example, the African school?
The African school, that's also a long story, but indeed, you remember this long personal story? I would say this is why medicine for me is really important. And this is why with this Physiques Sans Frontières, so the idea was to bring and to be helpful. I could not do medical thing because I'm too sensitive to blood, let's say. So I wanted to do something useful that way. So this is why I started with Physiques Sans Frontières. Then the African school came much later on because I get to meet people. You need to build up a team.
Okay.
And because I had this
Physics
first
is a
experience.
Physicists Without Borders.
Exactly, yeah.
Interesting.
Which is now, so that was the first version, but now the official version is ICTP, whom ICTP in Trieste was used to be the gateway for all the African countries as well. So in Trieste, so they are with UNESCO as well. So that's why. So this webinar series also will be with ICTP, and I think it's really like important people as well for us and for everyone.
This in-kind contribution to ESS, that is your main business here at ESS.
At ESS, yes,
Yeah.
but this is external.
How does it work? How does that work?
A lot of
Does
data.
it work? Does it make, do you make any progress with this in-kind? It looked very complicated
It
because
is
you have
complicated.
to
But how
put together
else?
all these different countries.
And how else can you do it? I mean, there are different models indeed, but the in-kind was at that time the best that we find out.
But at Fermilab, you didn't have any in-kind.
No, but this is government. This is different. And you know that they're not in easy position right now. So it depends on the government, especially. So in this case, this depends on all the countries. CERN could have been a model. This is what we tried when you were here at the beginning. We tried to have that one chart like easy, but it doesn't work like this anymore. So
it would have been easier, would it?
It would have been so much easier.
So it's quite complicated.
So that was the best possible, yeah.
But do they keep the time?
This is not
To
only
deliver?
the in-kind, it is everything. We are greenfield, remember. We do our best, yeah. And we are experts,
Speaking
so
of.
we have to, exactly, to respect this.
Thank you very much. I think you can.
Yeah, thank you.
Mhm.